Welcome to the Network Access Control presentation. This presentation will give you a clear overview of Network Access Control, NAC. We'll cover what NAC is, how we'll implement it, the timeline for its rollout, and what impact it will have on you. What is Network Access Control? Network Access Control helps us manage and secure access to both local area networks, LAN, and wireless networks. Its primary goal is to assess any device attempting to join the network, whether via a physical cable or Wi-Fi, and decide whether to allow or deny its connection. The core idea behind NAC is to prevent vulnerable or malicious devices and actors from gaining network access. An unauthorized device can easily compromise the entire environment, making it simple to breach other connected devices. While we work to secure existing hardware, we must also proactively prevent anything new from gaining access. Our environment will be implementing Forescout as its network access control platform. Let's explore how Forescout NAC functions. Forescout NAC listens to all traffic passing through the environment, including connections from IPsec tunnels or VPNs. It learns details about each device, such as its MAC address, IP address, and device type. For devices already joined to the network, NAC can query additional criteria like the domain they're connected to, the logged-in user, operating system details, and the device's posture. NAC builds a database of these assets, classifying devices by function, network role, and operating system. Based on this information, it performs posture checks and compliance checks. We segment devices according to business units and sites, wireless, LAN, etc. Devices are then further classified as compliant devices, non-compliant devices, corporate devices, non-corporate devices. We then apply policies and restrictions based on these classifications.
Let's talk about integration and enforcement actions. Beyond the devices deployed in the data center, Forescout Network Access Control integrates with on-site hardware. Switches. Integration with switches allows NAC to gather details on all devices connected to the local area network at a site. Wireless networks. NAC integrates with wireless controllers and access points to gather information on all devices connecting to any wireless network, including guest and corporate networks. When restrictions are applied, they are enforced via these integrations. Examples of enforcement actions. Let's say a non-compliant Linux device with vulnerabilities or malware is plugged into a corporate network. The moment it connects, NAC detects it's a non-corporate device and flags it as non-compliant. NAC then communicates directly with the switch to either disable the port the device is connected to, move the device to a remediation VLAN. If it's a corporate Windows machine, which is the helps of Windows 11, missing required software like CrowdStrike, the device can still connect to the network but only access necessary updates and software to become compliant. This allows service desk or on-site tech to log in and perform updates. If a device poses a major security risk or isn't a corporate asset, NAC can completely block it from the network. How will Forescout Secure Connect agent get installed? Our Windows laptops and desktops have a Forescout Secure Connect agent automatically installed via Endpoint Central. This agent gathers comprehensive information from the device, including running processes, installed applications, domain and connected users, OS version and updates, compliance checks. This agent also allows us to take action if direct port action isn't possible. For example, if a device has CrowdStrike but lacks the latest updates, we can push an update, stop an application, or start a process remotely via the agent. How will NAC manage non-compliant devices? When a device is detected as non-compliant, an alert is generated on our side, sending a notification to the network team and logging a service desk ticket for action. Wi-Fi devices. On the wireless side, non-compliant devices attempting to reconnect will be denied access by the wireless controller. Users will experience a failure to connect to the Wi-Fi. This is an immediate indicator of a non-compliant device during implementation. Switched devices. For devices connected via switches, NAC typically changes the VLAN to remediation VLAN. The user then obtains an IP address in this VLAN, granting access only to run required updates and applications, such as Windows updates. Access to other network resources is blocked.
If a device presents a critical security risk that can't wait for remediation, NAC can completely shut down the port. NAC automatically handles these actions. If a device is moved to VLAN RISE 77 and once it becomes compliant, verified by another compliance check, NAC automatically changes the VLAN back to its original configuration. If a port is shut down, NAC has a built-in trigger to automatically unshut the port after a period, rerun the compliance check, and if still non-compliant, shut it down again. This is because a shut port prevents further learning about the device's compliance status. During the initial rollout phase, we primarily use the remediation VLAN RISE 77 action to avoid disrupting the environment. Blocking actions are only enabled after a full rollout and when we're confident in the system's stability. Other NAC actions include Secure Connect restrictions. We can apply restrictions via the Secure Connect agent, such as blocking access to certain networks, restarting applications, or forcing updates. Firewall policy restriction. Integration with the firewall allows for actions like applying a virtual firewall on the local machine via the Secure Connect agent to restrict traffic based on device detection. What is the NAC implementation process? The implementation process involves initial contact and integration. We'll contact you to set up integration with your on-site devices, wireless controllers, APs, switches, via SNMP and SSH. Monitoring mode. Initially, NAC will operate in monitoring mode. No actions will be taken and no policies or restrictions will be applied. NAC will simply gather information from your network, learning about all connected devices. Landscape assessment. We'll provide a clear picture of all devices connected to your network, including classifications, e.g. 500 devices at a site, 10 printers, 20 CCTV cameras, 60 mobile phones, corporate laptops, desktops, etc. We'll also identify non-compliant devices, e.g. 3 laptops missing CrowdStrike, 1 missing DLP. Remediation planning. We'll liaise with our end-user computing, EUC, and other teams to check if non-compliant corporate assets are reachable and why software isn't installed. They will also likely liaise with you directly. Enforcement decision. Once corporate assets are largely compliant, we'll decide with you whether to enforce policies on the LAN, wireless network, or both, based on the number of non-compliant users and manageability. Our priority is to remediate corporate assets before any blocking, to minimize disruption. How will NAC handle guests in the network? Guest networks follow a different process because we can't interrogate guest devices due to external restrictions and security policies on those devices. This could trigger alerts on their end. From a network perspective, we cannot interrogate guest devices. Therefore, the security policies applied to your guest network must be configured to prevent any local access to your internal network. Guest networks should only provide internet access. If a third party requires access to internal resources while on site, we expose that access via VPN. The user would connect to the guest network for internet access, then establish a VPN connection into our firewall. This VPN connection would have specific restrictions, allowing access only to necessary internal servers or ports. We are exploring if some wireless network controllers offer basic posture checks, like OS checks or antivirus presence for guest devices, though functionality varies. Addressing guest VPN access concerns. VPN client installation. Yes,
Guests would need to install a VPN client to connect. Pharma distribution scenario. For pharmaceutical company visitors who need internet access for a day or during meetings, simply connect them to your guest network. This network provides internet access only and prevents access to your local machines or servers. Restrictions on internet access. Standard firewall policies will apply to guest internet access, blocking malicious websites, phishing sites, P2P networks, and gaming. Business applications and services like Office 365 will remain accessible. Ubiquity Wi-Fi policies. For Ubiquity Wi-Fi guest network policies, we will need to schedule a separate call to discuss specific setup and configuration. Remember, guest networks should always be segmented into their own VLAN and subnet, with policies on the firewall preventing access to other network segments and only allowing internet access. Access control and device policies can also be applied to the wireless network itself upon device connection. What are the next steps regarding deployment? No implementations will occur without the on-ground team's awareness and will be done formally through change management. We'll liaise with you before any on-site work to ensure all requirements are met. For any questions or concerns, please contact our SSA networking team. We appreciate your time and look forward to a smooth collaboration on the NAC implementation.